Hi there, Dr. Tashawn here, and in this video, let's review writing equations of lines. On the screen over here, you can see some formulas that we have. It starts with the slope formula. When you're writing the equation of a line considering linear functions, the first thing you need to know is the direction they're going, the steepness, the direction that they're going. Is it a positive steepness, a positive slope slanted this way? Might be a negative slope slanted this way. Maybe it's a vertical line, maybe it's a horizontal line. So we're going to take a look at each style. But you do need to find the steepness of the line first. So to find the slope of a line, we use the letter M in the formulas to represent slope, and it's rise over run. So rise, it's just how far do you rise, changing the y's over the run, the change in the x's. Okay, so you're going to go up and over, and you're going to just figure out, count that. Also, you'll see a lot of times notated, you'll see delta y over delta x, those triangles there, that's Greek letter capital delta. When you see delta in a mathematics class, when you do capital letter Greek letters, in a mathematics class, it means a change in something. It means the difference. So you're going to subtract the y's, the difference of the y's in the numerator, and the difference of the x's, okay? So in whatever order you subtract the y's, subtract the x's, just make sure you're consistent and do the same order. And then we have equations of lines, many different forms of equations of lines that have been proven to be true. And which form do you use? Maybe whatever your teacher asks you to use, or depends on, are you using technology or do you have to use intercepts? It depends on what you're using it for. So I usually start with the point slope form. That's, most of the time you find the slope, you have a point, you need a slope, just plug it into the point slope form, it's given right there to you. Slope-intercept form, y equals mx plus b, that's to get y equals by itself. So a lot of your graphing calculators, you want to write the equation of a line in the graphing screen. So they're going to ask you to put it in function notation and y equals notation. So there's advantages to that. Also, you can pinpoint what the slope of the y-intercept is right away. General form, ax plus by plus c equals 0. A, b, and c are integers, okay? So A, B, and C are integers, A and B aren't 0, and that's what your general form looks like. In general form, you can usually find the intercepts pretty quickly and pretty easily. Vertical line, x equals a number, horizontal line, y equals a number, and again, we're going to do 5 examples. So 5 examples, so we're going to take a look at each of those. Our 5th example will have to do with parallel and perpendicular, so we'll talk about slopes of parallel and perpendicular, which I've included over here. So let's go ahead and jump into the examples. Here is example number 1. Example number 1 gives us the slope is -3. And it also wants us to write the equation of line containing the point 4, 1. So which form is our go-to form here? We'll take a look. They tell us the slope, they tell us the point, let's use point slope form. If they give you the point, they give you the slope, let's use point slope form. Remember what point slope form looks like. So y minus the y coordinate equals your slope quantity x minus your x coordinate. This is what your point slope form looks like. The slope given to us goes in the M spot. This is the slope. All right, that's given to us here. And then the point, the x coordinate of the point, that is your x sub 1. The y coordinate of your point is the y sub 1. What you essentially do is you just make substitutions now into your equation. So you're going to take your y minus your y coordinate goes here. Okay, then your slope, substitute your slope. We're just making substitutions, and then you bring down x, and then minus, and your x coordinate goes here. So here is your point slope representation. Here is the point slope representation of the line. You can see the slope, you can see the point. All right, now we want to write our answer y equals mx plus b form. So just a couple more algebraic maneuvers to get y equals mx plus b form. We'll take the slope and distribute it to remove the grouping symbols, and then we'll add that y-intercept to the other side, okay? So like I said, so the first thing we're going to do, remove the grouping symbols, so distribute the slope, okay? So distribute the slope, y minus 1 equals -3 times x, okay? -3 times -4 is a positive 12, so we're here. And then finally we want to, let's move the y-intercept to the other side. So we want to add 1. We don't want y minus 1. We're trying to get y equals. Add 1 to both sides. So y equals -3x plus 13. Here is the equation of the line given in slope-intercept form, y equals mx plus b form. So point slope form, slope-intercept form, in case you wanted to plot. So the slope is at -3, the y-intercept crosses the y-axis at 13. We're going to look a little bit later, I'm going to make another video with graphing linear functions, so we want to be able to write the equations of them in this one. Let's take a look at example number 2. Example number 2 gives us 2 points. We want to write the equation of a line passing through 2 points. There's a theorem from geometry that says given any 2 points, you can write a linear equation through any given 2 points. So we want to write the equation of a line through these 2 points right here. We're given 2 points. So what do we need to find first? Okay, we need to find the direction the line's going. You need to find the slope. We need the slope and a point to write the equation of a line. If they give us the slope like example 1 did, good to go. Right? But here they did not give us the slope, so we will have to compute, we're going to compute the slope. We need to find the slope first. So to find the slope, we want to, also called m in the formula, okay? We want to subtract the y coordinates in the numerator, the x coordinates in the denominator. I'm going to label these, okay? So I'm going to call this my first ordered pair. So here's x sub 1 and y sub 1. I'll call this my second ordered pair. So this is my x sub 2 and y sub 2. So we want to subtract the y's in the numerator, x's in the denominator. I can set up a little template for myself here, okay? So here's my fraction bar. Subtract the y coordinates in the numerator, the x's in the denominator, and be careful how you set this up, all right? So what are my y coordinates? Let's say I'm going to go y2 minus a y1. My y coordinates are 1 and -2. So 1 and -2. I'm doing the y2 minus y1. In the denominator, x sub 2, which is 2, minus x sub 1, which is 4. So 2 and minus 4. Just make sure you're consistent when you set this up. So I took my slope formula and I used y2 minus y1 over x sub 2 minus x sub 1. Make sure you're consistent. Doesn't matter which order you do this in, but as long as you're consistent, what you do in the numerator, same in the denominator. Now compute 1 minus a -2, that's positive 3. 2 minus 4, that's a -2. So this is what our slope is right here. Okay, so our slope is a -3/2. That's the slope that we need to use for our line. That's the direction of our line. It's negative slope, so it's going to be slanting this way. So we have the slope is -3/2. All right. So we've got the slope, we need a point. We have 2 points to pick from. Which point should we use to write the equation of a line? It doesn't matter which one you pick, they will both work. Let's start with 4, -2. Let's pick this one first. We'll do both just so we can show you so you can see that it just doesn't matter. So we'll pick this one first, all right? So we have a point and a slope, okay? So we point and a slope. So let's go ahead, right to point slope form. Y minus y coordinate equals slope quantity x minus the x coordinate. If you have a point, you have a slope, it's easy to plug right into this. Okay, so you have y minus your y coordinate is a -2. The y coordinate equals your slope. You're just making substitutions, -3/2, just make your substitutions, and then we have x minus, and the x coordinate is 4, right? The answer's being asked for in y equals mx plus b form. So we have the 2 more steps, right? Get rid of the grouping symbols by distributing the slope, and then we're going to add that y-intercept to the other side. So let's distribute, remove the grouping symbols, just do an algebraic techniques. Y minus a -2, so minus a negative, let's turn that into positive. Distribute -3/2 times x, and then negative times negative is positive. 3/2 times 4 is 6. And finally, we want y equals, not y plus 2 equals. So let's subtract 2, subtract that y coordinate from both sides. You end up with y equals -3/2 x plus 4. Here is the equation of our line for example number 2. Here's the equation. So, but we have to do this one more way, don't we? Okay. What if instead of using the point 4, -2, what if instead of using the point, what if we use 2, 1, the other point instead? So we'll have our slope of a -3/2. but we're going to use the 2, 1 instead of the 4, negative 2. What if we use the other point? Is that going to change anything? All right, well, let's see. All right, again, we have a point, we have a slope. So y minus the y coordinate equals your slope, quantity x minus the x coordinate. If you have a point, you have a slope, point slope form. All right, substitute, so you have y minus your y coordinate is 1. Slope is negative 3/2. X minus your x coordinate is 2. Substitute. And then let's go ahead and write y equals, so the algebraic steps would be to remove grouping symbols, so distribute your slope. All right, so you have y minus 1 on the left equals negative 3/2 times x, and a negative times negative is positive, 2's cancel, so we're here. And then finally, isolate y. We don't want y minus 1, we just want y. So move that y coordinate to the other side. So the ones cancel, y equals, here's your negative 3/2 x and a positive 4. So here's your answer, which look, it matches, it's the same thing. It's the same thing. So you're going to, given 2 points, you compute the slope first. We need the direction the line is going. Then once you get the slope, it doesn't matter which point you use. So you'll get the same answer either way. So just use a little strategy. Take a look at your slope and look at the numbers and see if one might be easier than the other. Okay, in this case, they're both about the same. All right, so here's example number 2. All right, now I'm going to erase. We're going to do example 3 and example 4. So let me erase here. So example 3, let's take a look at how we would write the equation of a vertical line. We'll do that with example 3. And then example 4, let's take a look at a horizontal line. So let's do example 3 and example 4. All right, so example 3 is going to be our vertical line. And let's call it, so here's example 3. Let's write the equation of a vertical line, vertical through, we'll say the point 2, 3. And then example 4, let's write the equation of a horizontal line, through that same point 2, 3. So let's take a look at a vertical and a horizontal, how we set up those equations, all right? So you can see on the screen over here, vertical line, x equals a number, horizontal line, y equals a number. Little different strategy to work with vertical and horizontal. Those, if you will, would be called your special cases here. So let's start with vertical. So let me go ahead and sketch, here's a y-axis. Okay, so here's our y-axis, here's our x-axis. X-axis and y-axis, and I'm going to go ahead and plot the point 2, 3, and I'm just estimating here. I'm just estimating. So from the origin, we're going to go 2 on the x and then up 3 on the y. So let's say that 2, 3. This is our point right here, and let's go ahead and draw a vertical line through this point. Okay, so just sketching it. So here's the blue vertical line through that point 2, 3. All right, so before we do anything more, let me name a few more points on this line. Let's just name, we're just going to estimate the values, right? So let's name, let's put a point maybe right about here. Okay, so let's estimate, where would this be? Well, from the origin, you're still got to get to the blue line. We're still going 2 on the x. We're still going 2, but instead of going up to 3, let's say maybe we only went up to 1. Just estimating the points on this line, okay? Let's do another one, okay? So let's go over to 2. Let's put one up here. All right, so maybe this is, you're gonna go over to 2, and then let's say maybe we're going up to past 3, so maybe to 4, okay? Just estimating some points, all right? What if we put a point down here, okay? So then let's see from the origin, that could be 2 on the x, maybe -1, because we're going down on the y-axis, okay? All right, maybe we can put a point way down here, okay? So where might this be? Well, it's definitely going 2 on the x, and then maybe down, I don't know, how far is that? Maybe let's call it -5 to -5, okay? So here's some points. I named some points on my vertical line. So now how many points are on my vertical line now? How many points? Maybe that's a tricky question. So how many points? There's infinitely many points on a line, right? Linear functions, lines contain infinitely many points. I named 5 of those points. I have 5 of them named here, but there's infinitely many points on that line, all right? So, and we can keep going. You can just keep naming and estimating. So we want to write the equation of this line. So how do we write the equation of this line? Well, the strategy we would use for the other examples, you know, we would compute the slope, right? You got to know the direction, compute the slope. Remember that whole talk. All right, so compute the direction, find the slope. Well, now that we named enough points, let's go ahead and see what happens if we take those 2 points here and we compute the slope, okay? So computing the slope, remember that you're going to subtract the y coordinates in the numerator, so 4 minus 3 in the numerator, subtract the x coordinates in the denominator, so 2 minus 2 in the denominator, okay? So what do we have in the numerator? 4 minus 3 is 1, and what do we have in the denominator? 2 minus 2. And it doesn't matter which of the points you pick, the x's are the same, and you're going to have a 0 in the denominator. So 0 in the denominator means that we're dealing with undefined. Undefined. Remember when there was another video out there when I talked about dividing by 0. So a non-zero divided by 0, there's no solution. There's no way to achieve this. Okay, so I mean equals, well, you know, when you use a division problem, you could multiply the answer times the divisor to get back the dividend. So what number can you multiply 0 and get 1? Okay, what number times 0 gets 1? Nothing works. So this is not defined. 0 in the denominator is not defined. So then what do? You take the slope and you take a point and slope, and you plug it into point slope form, and you could write your equation, but you can't plug undefined. You don't write that in an equation. So we have to write the equation of this vertical line, and there's going to have to be another way to do this, because plugging in a point and a slope to the point slope form is not going to do it here. So what's the other? Well, let's take a look. Okay, take a look. Remember, there's infinitely many points on this line. Infinitely many points on this line. I named 5 of them. I named 5 of them out of the infinitely many. Take a look at the 5 that are named. What do they all have in common? What do all these points, every single point, as a matter of fact, all the infinitely many points, what do all the infinitely many points have in common on this line? The x coordinate is 2. The x's are all equal to 2. This is why when you name a vertical line, anytime you name a vertical line, it's always going to be x equals, and you choose the x coordinate of your the line is the point is passing through. Okay, so that's the idea with vertical. Let's similar with horizontal. So I'm not going to go into as much detail with horizontal because you could apply it, but let's take a look at example number 4. Let's take a look at a horizontal line. Horizontal line. So let me start by sketching. So here's a y-axis, and here's an x-axis. And let's plot this point. Okay, so plot the point. So to the right 2 and up 3, and I'm going to use the same location. Okay, so here's the point 2, 3. All right, and here's the point 2, 3, and we want to draw a horizontal line through this. Okay, so let me draw the horizontal line. All right, let me move the 2, 3 over here so you can see it. Okay, and horizontal line through this point. All right, so we want to write the equation of this horizontal line. Well, let's name some, estimate some other points that are on this line. Okay, I mean this point right here, right on the y-axis, means you're going 0 on the x. Okay, and then up 3 on the y because it's up 3. Okay, maybe this point over here. All right, this point over here, let's see, we're going out a little bit farther on the x. I'll call it 5 on the x, but you're still going up to 3 on the y-axis. Okay, maybe this point right over here. Okay, what could this point over here we call? Well, we're going to the left on the x-axis, so maybe, I don't know how far left, -1, -2, whatever you want to call it, we're still going up 3. Okay, so we're still going up 3. All right, I don't know if we need more points than that. I can put one way out here if you want. Okay, maybe we're going out to 8 on the x-axis, but we're still going up 3. All right, so how many points are on this horizontal line? How many points are on this horizontal line? Infinitely many points are on this horizontal line. How many points did we name? We named 5 points, but there's infinitely many points on this horizontal line. We named 5 of them. So you could take 2 of those 5 points, get the slope point, plug it in, right? Or you can notice the pattern, okay? So what is the pattern here? Well, look at all these points I named, okay? What do they all have in common? What do these points all have in common? As a matter of fact, every single one of the infinitely many points on this horizontal line, what do they all have in common? Okay, well, the y-coordinate is 3. So y equals, the y-coordinate is how you name a horizontal line. All right, so if you know where the point is that it passes through, your vertical line is just always going to be x equals the x-coordinate of the point, because the infinitely many points on a vertical line will always have the same x-coordinate. That's why we name it that way. If it's a horizontal line, infinitely many points on the horizontal line, your equation will always be y equals the y-coordinate it passes through, because all the infinitely many points on your horizontal line always have the same y-coordinate. So hopefully this helps with a vertical and horizontal. And we have one more example to do. Okay, so let me erase here one more example. Let's take a look at example number 5. So example number 5, we're going to get into the parallel and the perpendicular concept a little bit. More the perpendicular than the parallel, but we'll talk about both of them. So example number 5 is, we want to write the equation of a line perpendicular. The symbol for perpendicular is this. Upside down capital T is a symbol for perpendicular. So perpendicular to the line equations 4x minus 3y equals 9, and containing the point negative 3, 1. Okay, so this is our example here. So we want to write the equation of line perpendicular to the given line through the point. So we're back to, the horizontal and vertical are your special cases, okay? So now we're back to, what do we need to write the equation of the line? We need to know the direction, we still need to know the slope, and we need the point given to us, so we need the slope. So perpendicular to this given line, I'm going to start by working with this given line. We're going to take the 4x minus 3y equals 9, and we perpendicular to, so we need to pull the slope of this line. We need to figure out what the slope is, and how could we do that? You see that they're giving us the equation in almost general form, just about general form, the ax plus by equals c. So they're giving it to us in that form. And so we want to pull the slope. We would like to transfer it into an equation, one of our equations of lines that has an m in it. So any of these have an m in it. Well, we could put it in y equals mx plus b form. Let's take this equation, write it in slope-intercept form, because when it's in slope-intercept form, we can pull the slope. All right, so which means we need y equals. So how are we going to get y equals? Well, we got to isolate the y, so let's start by taking away the 4x from both sides. So subtract the 4x from both sides. On the left side, the 4x's are going to cancel, so negative 3y, okay, equals a negative 4x and a positive 9, all right? And we want y equals, not negative 3y, just y equals, so let's move the negative 3 out of the way, divide every single term by the negative 3. So the negative 3's are gone here, so y equals negative over negative cancels, 4/3 x and then minus 3. Here's the equation, same thing, okay? These two equations represent the same line. This is slope-intercept form, and this would be your general or linear form. So in this form, y equals mx plus b, we can pull the slope here. We can pull the slope. We see the slope has got to be 4/3. That's what the slope of this line is. Now, it's not the slope we're going to use for this problem though, because we want the slope, we don't want the slope of this line, we want the slope of the perpendicular to this line. So if the slope of this line is 4/3, how do we figure out the slope of the perpendicular? And that's where these rules come in. If two lines are parallel to each other, two lines running the same way, the steepnesses are going to be the same. Two lines are parallel to each other, slopes are equal. When two lines are perpendicular, well, one line this way, one line, two lines are perpendicular, well, then the product of their slopes is always -1. When you take and multiply them, you always get -1. Okay, that's what the theorem is about perpendicular lines. To figure out what the actual slope of the perpendicular is, you would take the negative reciprocal of the slope given to you. So you would take whatever the slope is of the line, you would change the sign, okay, positives become negative, negatives become positive, change the sign and the reciprocal, so flip the fraction. This is the slope that we need to use to write the equation of our line. Okay, we want to write the equation of a line perpendicular to, so we have to choose the negative reciprocal. So we've got the slope we need. So the slope that we need, and it's the slope of the perpendicular, is -3/4. That's the slope we need to use. The line is -3,1. -3,1 is the point we're using. And we want to now write the equation of the given line with this slope passing through that point. Now look, we have a point slope, so let's jump to our point slope form and substitute in our values. So you have y minus the y coordinate is 1 equals your perpendicular slope that they're asking us to use is -3/4. Just substitute it in x minus x coordinate is -3, so minus a -3, and I'm just going to write minus a negative is +3. All right, we want the answer in y equals mx plus b form, so algebraic steps, 2 more of them. Algebraically remove the grouping symbols on the right hand side by distribution, and then add the y coordinate. We'll do one at a time. So the left side, y minus 1, the right hand side, -3/4 x, and then when you multiply here, -9/4. Distribute. Move the y coordinate over. Add 1 to both sides, move the y coordinate. So we have y by itself. Y equals -3/4 x minus 9/4 plus 1. Get a common denominator, right? So -9/4 plus 4/4 gives you a -5/4. Okay. And here we go. All right, so here is the equation y equals mx plus b form satisfying the conditions for example 5. All right, hopefully this helps you with a review of a lot of what you learned with writing equations of lines from an algebra class. I hope this helps, and thank you so much for tuning in. Appreciate you, and that's it. Thank you. I appreciate it. Bye-bye.